Hey, welcome back. We're in example 3 using half-angle identities to evaluate trig expressions, and I want to find the exact value of the cosine of 75 degrees. 75 degrees is not a special angle on the unit circle, but if I double 75, I get 150, and 150 degrees is equivalent to 5 pi over 6. So this would be the coordinate for my angle at 150 degrees, which is a special angle on the unit circle. So I can rewrite the cosine of 75 degrees as the cosine of 150 degrees divided by 2. So I would need a half angle identity for cosine, which would be this identity, and 75 degrees is a quadrant 1 angle where cosine is positive. So I'm going to use the positive square root as my identity. So I'll have a square root of 1 plus the cosine of 150 degrees. That's asking for the x coordinate at that angle, and that's a negative square root of 3 over 2. And that's being divided by 2. That's all under the square root. So I'll have under my square root, when I get a common denominator and combine that fraction, I'll have a 2 minus the square root of 3, all divided by 2 in my numerator. Dividing by 2 is the same as multiplying by 1/2, and that equals 2 minus the square root of 3 under the radical in the numerator, and then the denominator, 2 times 2 is 4. Then recall, when you have a fraction under a square root, that's equivalent to the square root of the numerator divided by the square root of the denominator, and the square root of 4 is 2, and that would be my exact value for the cosine of 75 degrees. I can check that in the calculator, making sure that I'm in degree mode. And I'm going to evaluate the cosine of 75 degrees in the calculator, and I'm going to compare that decimal approximation to the decimal approximation for the exact value that I just found. So in the numerator, I have a square root of 2 minus square root of 3, and then that's over 2. And press enter, and I can see that the decimals match for my exact value and the cosine of 75 degrees. So I know that that works. Okay, now we're going to try the sine of 7 pi over 8. So when I look at the unit circle special angles, there is no 7 pi over 8 as a special angle. If I double that 7 pi over 8, then that would be 7 pi over 4 times 1/2. Right? So 7 pi over 4 is double 7 pi over 8. So 7 pi over 8 is equivalent to 7 pi over 4 times 1/2. So I'll be using a half angle identity for sine. Okay, so I'm going to take, since I'm looking at 7 pi over 8, and half the circle is 8 pi over 8, 7 pi over 8 would be in quadrant 2, and sine is positive in quadrant 2. So I'm going to need the positive square root. In the numerator is 1 minus the cosine of that angle, 7 pi over 4, and 7 pi over 4 is here in quadrant 4, and I have a sine or sorry, rather cosine value there of positive root 2 over 2. So I'll substitute that in for the cosine of the angle. Okay, then that is divided by 2, and that's all under the square root. So getting a common denominator, combining those fractions, we'll have 2 minus the square root of 2, all divided by 2, and then dividing by 2 is the same as multiplying by half. And now we have 2 minus the square root of 2, all divided by 4, and that is under the radical. So taking the square root of the numerator over the square root of the denominator, we'll have the square root of the quantity 2 minus root 2, all divided by 2. And we don't need to rationalize since there's no radical in the denominator. Again, we can use the calculator to check. I want to make sure now that I'm in radian mode, and I'm going to evaluate the sine of 7 pi over 8 and compare that with the decimal equivalent of the answer that I just found. So I have a square root of the quantity 2 minus square root of 2 in my numerator, divided by 2 in the denominator, and when we compare those decimals, they're equivalent, and so we know that that checks.